Welcome to this training on electrical safety. A basic completed electrical circuit requires three things to function correctly: an electrical source, wires, and an electrical user. An electrical source can be a battery or the power from an electrical outlet supplied by your local utilities or a generator. Wires connect the electrical source with the electrical user. The wires are also important in that they must be rated properly for the circuit. If too much electricity flows through a wire, it may become overheated and fail. This could result in an electrical fire. An electrical user is anything that uses electricity to operate, such as a bulb, power tool, or machine. Shock results when the body becomes part of an electrical circuit. Current enters the body at one point and leaves at another. Typically, a shock occurs when a person makes contact with both wires of an energized circuit, one wire of an energized circuit and the ground, or a metal part in contact with an energized wire while the person is in contact with the ground. The severity of injury from an electrical shock depends on the amount of electrical current and the length of time the current passes through the body. For example, 1/10 of an ampere, or amp, of electricity going through the body for just 2 seconds is enough to cause death. The voltage of the electricity used to power the tools and equipment in your workplace may be significantly greater than what you will find in your home. Increasing the voltage increases the current. This means a life-threatening injury or death can occur after a shorter amount of time in contact with a higher voltage circuit. A severe shock can cause much more damage to the body than can be seen. A severe shock can cause internal bleeding and serious damage to tissues, nerves, and muscles. Shock is often only the beginning of a chain of events. Sometimes the hidden injuries caused by electrical shock result in a delayed death. Even if electrical shock is small, your reaction to it may cause you to fall, causing bruises, broken bones, or even death. Effects on the body, 1 milliamp. This level of exposure has a minor impact but can be felt by the human body. 2 to 10 milliamps. Minor shock is possible if exposed to this level. If working from an elevation, a fall could result. 10 to 25 milliamps. If exposed to this level, you may lose muscle control and be unable to release or let go of the current. Free the victim using a non-conducting material such as wood. 25 to 75 milliamps. Exposure causes pain and may lead to collapse or even death. The longer the person is exposed to this electrical current, the more likely death will occur. 75 to 300 milliamps. Even for a quarter of a second, this exposure is almost always immediately fatal. Exposure may also cause ventricular fibrillation. Emergency response. If a coworker receives an electrical shock, you should take immediate action. Shut off the electrical current if the victim is still in contact with the energized circuit. Do not touch the victim if he or she is still in contact with the electrical circuit. You do not want to become a victim too. If you cannot get to the switch quickly, pry the victim from the circuit with something that does not conduct electricity, such as a wooden or fiberglass pole. While you do this, have someone else call for help. Once the victim is no longer in contact with the electrical circuit, call out to the victim to see if he or she is conscious. If the victim is conscious, tell him or her not to move. It is possible for a shock victim to be seriously injured but not realize it. If you are trained in first aid, attend to the victim. Do not leave the victim unless there is absolutely no option. Electricity is one of the most common causes of fires. Defective or misused electrical equipment is a major cause of electrical fires. If you encounter a small electrical fire, first call 911 or another emergency services. If you are trained at the use of fire extinguishers, make sure the fire is not out of control. Find the proper fire extinguisher and extinguish the fire. If you are not suitably trained or the fire is too big, evacuate the area immediately. Injuries typically occur when safe work procedures are not followed when working on electrical equipment, hazards are not understood or taken seriously, or when safety systems are ignored. To be safe, you must think about your job and plan for potential hazards. Use the three-stage safety model. Recognize, evaluate, and control hazards. The first part of the safety model is recognizing the hazards around you. Hazards can be found in the following areas: damaged insulation, defective power tools, inadequate wiring, exposed electrical parts, overhead power lines, an explosive atmosphere, or wet equipment, location, or worker. Extension cords are common at work and in the home. You should always inspect extension cords before use. Inspect the plugs for bent or missing prongs. Inspect the outer jacket or insulation of the cord for cuts, abrasions, or signs of wear. Is there evidence of internal damage, such as pinched or crushed outer jacket? If the cord is damaged, remove it from service. Portable power tools need to be taken care of and properly inspected before each use. Always inspect the tool's cord and plug for damage, just as you would with an extension cord. Look for damaged insulation, broken prongs, or heat and sparks. Never tamper with or bypass electrical interlocks or other safeguards. If you find that a tool is damaged, starts sparking, or is getting hot, remove it from service and have it repaired or replaced. An important consideration for electrical safety is the gauge or thickness of the wire relative to the current it has to carry. The smaller the gauge number, the thicker the wire. An electrical hazard exists when the gauge of the wire is too small for the current it carries. This may occur when you use an extension cord. The gauge of the wire may be too small for the equipment. A tool is more current than the cord can handle without tripping the circuit breaker. The wire will overheat and could cause a fire. Be alert for exposed wires and parts. Wires and parts can be exposed if a cover is removed from a junction box or a breaker panel. The overhead wires coming into a building may be exposed. Electrical terminals in motors, appliances, and electronic equipment may be exposed. Older equipment may have exposed electrical parts. If you make contact with exposed and energized electrical parts, you may be electrocuted. Shocks and electrocutions occur where physical barriers are not in place to prevent contact with electrical wires. When dump trucks, cranes, work platforms, or other conductive materials such as pipes and ladders contact overhead wires, the equipment operator or other workers can be killed. Many people do not realize that overhead power lines are usually not insulated. More than half of all electrocutions are caused by direct worker contact with energized power lines. Most electrocutions involving overhead power lines are caused by failure to maintain proper work distances. If you do not maintain required clearance distances from power lines, you can be electrocuted. Because water is such a good electrical conductor, working in wet conditions with wet electrical equipment is hazardous. If you touch a live wire or other electrical component while standing in even a small puddle of water, you'll receive a shock. You do not have to be standing in water to be shocked. Wet clothing, high humidity, and perspiration may also increase the risk of being shocked. Always contact your local utility company before beginning a digging or trenching operation. If underground lines are present, their location will be marked. Sparks from an electrical tool or an electrostatic discharge can ignite flammable materials. You should not use portable power equipment in rooms that are known to contain flammable substances, even periodically. Rooms that contain flammable substances require special explosion-proof electrical systems. The transfer of flammable liquids from one container to another should be done only when containers are bonded, electrically interconnected. When filling portable gas containers at a gas station, place the container on the ground, grounding the container before filling it. These containers have been known to explode from static electrical discharge, spark, when left in a truck bed. The plastic container rubs on the truck bed, creating a static electrical charge that cannot reach the ground because of the truck tires. When the nozzle of the pump makes contact with the container, it acts as a ground. The resultant spark can ignite the fumes from either the nozzle or the container. Evaluating hazards. Once you recognize a hazard, the next step is to evaluate the risks it poses. Obviously, exposed wires should be recognized as a hazard. If the exposed wires are 15 feet off the ground, your risk is low. However, if you're going to be working on a roof near those same wires, your risk is high. The risk of shock is greater. You'll be carrying metal objects that could touch the exposed wires. You must constantly evaluate the risk you face to avoid being shocked. There are clues that electrical hazards exist. For example, if a ground fault circuit interrupter, or GFCI, keeps tripping, switching off, when you are using a power tool, there's a problem. Do not continuously reset or switch on the GFCI and continue to work. You must evaluate the clue and decide what action should be taken to control the hazard. There are a number of other conditions that indicate a hazard, such as sparking and overheating. Locking or tagging out circuits and machines can create a safe work environment. If you are working on or near machinery, it must be locked or tagged out to prevent its accidental startup. Never tamper with locks or tags, or try to repair or operate equipment that has been locked or tagged out. These activities should be conducted by an authorized employee as defined by OSHA and the Control of Hazardous Energy Regulation. The power supply must be turned off before working on a circuit. Once it has been shut off and de-energized, the switch to the circuit must be locked out so power cannot be turned on. The circuit can then be tagged out with an easy-to-see sign or label that lets everyone know that work is being performed on the circuit. Before beginning work, a qualified worker must test the circuit to make sure it's de-energized. Another way to control hazards is to use a ground fault circuit interrupter, or GFCIs. Unlike circuit breakers and fuses, GFCIs reduce the likelihood of fatal shocks by automatically switching off the power when a small amount of earth or grounding current is detected. Once the problem is fixed, the GFCI has to be manually reset. Temporary GFCIs required on construction site if the presence of electrical hazards is very prevalent. A worker could be using an electrical drill that is connected to a flexible cord set or extension cord. This cord set be where the plug head is inserted into a temporary power box. Grounding does not guarantee that you will not be shocked, injured, or killed by defective equipment. However, it greatly reduces the possibility. Another way to control hazards is to be sure not to use equipment with damaged grounding connectors. Some people might alter a 3-prong plug by cutting off the grounding prong so that they can plug it into a 2-prong receptacle. This practice is not safe because you are bypassing an equipment safeguard and setting yourself up for injury. Do not use an adapter that converts a 3-prong system into a 2-prong system. Again, this interrupts the grounding connection. These adapters are not designed to send current to the ground if there is a problem. Controlling hazards, OSHA requires that workers be provided with personal protective equipment, PPE, and PPE acts as the last line of defense between a person and a hazard and is rated for the voltage to which a person may be exposed. Because the hands are the most likely point of electrical contact, gloves are often worn to provide protection. Insulated shoes and masks also increase resistance by making it more difficult for the current to reach the ground.